Alright, in this last video, we're just going to have a look at the last two sections, which is reflections and translations for cubics. So again, let's just have a look at our general cubic graph. Now, like our quadratics, a reflection is a mirror image along the x-axis. So all these numbers here, or the values, okay, it's just going to be flipped around. So it's going to look something like that. That's all a reflection is. We just flip it from one to the other. If we had this one to start with, okay, same thing, we just flip it around. So along the x-axis, it's just the other way around. That's all reflections are. And that's indicated by the term at the front. So the A term, so we've got y equals ax cubed plus bx squared plus cx plus d. Okay. If this number here was negative, we'd have this. So for example, y equals x cubed is our standard in black. Okay, y equals minus x cubed would be the one in green. Translations, so that's moving it left and right. So again, just as a reference point, let's start with that. Now, say, okay, that's y equals x cubed. Let's say we had the graph of y equals x plus 2 cubed. Well, all that's going to do is, like our quadratics, where we move it left and right. Okay, this one, we're going to move it to the same thing, so the opposite signs. So positive becomes negative. So that basically our 0, 0 point is going to move to the left. And that's our reference point. Same shape, just moves it left. Y-intercept, okay, for our x cubed graph is at 0. For our this graph, what happens at 0? Well, 0 plus 2 cubed, 2 cubed is 8. So this value here is going to be 8. Okay, moving it up and down, so that's left and right. So if that was a negative, let's say it was x take 2 cubed, alright, it would go the other way around, so it'd be somewhere there. Okay, that's it. Positive 2 and minus 2. Moving it up and down, here's our x, here's our y. Alright, again, this one is y equals x cubed. Now, if I have y equals x cubed plus 2, okay, that 2 is not inside brackets, so that indicates that it's going to go up and down. If it's inside brackets, or inside that cubed part, then it's going to move it left and right. If it's outside the cubed, it's going to move it up and down. So these are very standard cubic graphs for the moment. So it's going to move it up 2. So that sign doesn't change. It just indicates at this point here, at 0, 0, is going to move up 2. So we're going to have 0, 2 there. Okay, inside the brackets moves it left and right. Outside the brackets, or outside the cube, moves it up and down. So if that was x cubed, take 2, we'd move it down 2 spots. At minus 2. So that's translations for the moment. We'll just have a look at some key features. Okay, as a bit of summary. So our general, like our turning point form for a cubic, looks like this. x take h cubed plus k, and we've got a at the front. So we've got a stationary point of inflection at hk. Okay, that stationary point of inflection is, okay, where it changes from concave down to concave up, or other way around. Okay, change of concavity at the stationary point of inflection. I've just put SPI, stationary point of inflection, is where the change of concavity. Okay, we're going down and we're going to go up. Okay, if we have a is greater than 0, it starts below the x-axis. If it's less than 0, it starts above. We've got one x-intercept is found by solving the equation, so this equation for 0, finding the x. And we've got, as normal, finding the y-intercept, substitute x equals 0. So there's some key features. You might want to write a summary. Next part, we're just going to have a look at a couple examples, and then that's it.